In a bold declaration, researchers have announced the discovery of an entirely new planet, unlike any previously identified. NASA, famous for its revolutionary research, has disclosed that this newly found planet is intriguing not just because of its size and position, but also because it emits light that appears to be artificial. Could this groundbreaking discovery be a sign that we are on the edge of unlocking mysteries that will radically change our comprehension of the cosmos? Does this revelation suggest the possibility of life existing on a planet beyond our own? As we delve into NASA's remarkable discoveries, we may soon uncover the truth behind these extraordinary lights. In 2007, NASA launched the Dawn spacecraft with a mission to investigate some of the most captivating objects in our solar system. Equipped with 3 ion engines, Dawn embarked on a journey that began with a 14-month study of Vesta, the second-largest asteroid in the belt. Dawn transmitted back intricate images and data, exposing Vesta's complex surface and rich geological history. Upon completing its mission at Vesta, Dawn proceeded with what was arguably the most exciting phase of its journey, an in-depth examination of the dwarf planet Ceres. Thanks to its ion engines, Dawn was able to leave Vesta's orbit and head toward Ceres, a feat traditional chemical propulsion methods could not have accomplished. These engines provided a steady thrust, enabling Dawn to travel vast distances and establish a stable orbit around Ceres. Discovered in 1801 by the Italian astronomer Giuseppe Piazzi, Ceres is the largest object within the asteroid belt between Mars and Jupiter. For many years, it was regarded as the smallest dwarf planet in our solar system until its reclassification in 2006. With a diameter of about 950 kilometers, Ceres is the largest and most massive body in the asteroid belt, making it one of the most intriguing objects because of its distinct features. Scientists eagerly awaited the first detailed images of this mysterious world, which revealed bright spots scattered across its surface, particularly within a large crater known as a crater. These bright spots immediately attracted significant interest among the scientific community. Before the Dawn mission, the best images we had of Ceres were blurry, low-resolution pictures captured by the Hubble Space Telescope. Very little was known about this dwarf planet, and the prospect of obtaining close-up images promised exciting new insights. The Dawn mission aimed to deepen our understanding of the solar system's formation and the role water played in the development of planetary bodies. The bright spots on Ceres, which were also observed on other asteroids, were believed to be composed of highly reflective materials, possibly salts left behind by sublimated water. This discovery hinted at the possibility of cryovolcanism on Ceres, a phenomenon where volcanoes erupt not molten rock but liquid water or brine. What exactly these mysterious lights are and what they reveal about Ceres remains an open question. Could they be evidence of ongoing geological activity, or could they indicate something even more remarkable? Ceres stands apart from other bodies in the asteroid belt due to its size, mass, composition, and potential for containing water and ice. Unlike typical rocky asteroids, Ceres has a composition more akin to that of a comet, suggesting it may hold valuable secrets about the early solar system. After 2 years of travel, the Dawn spacecraft finally began its approach to Ceres in early 2015, marking a crucial milestone in its mission as it prepared to send back the first close-up images of the largest object in the asteroid belt. The spacecraft drew closer to Ceres, revealing a world previously hidden from view. The initial images of Ceres displayed a cratered surface indicative of a long history of impacts. However, it was the bright spots within the dark, rocky terrain that captured the attention of scientists and space enthusiasts. As the resolution of the images improved, scientists developed various theories about these spots. Could they be patches of ice reflecting sunlight, or could they represent something even more exotic? Speculation ranged from mineral deposits to potential signs of cryovolcanic activity. To everyone's astonishment, closer inspection revealed that the brightest spot was not a single feature but a cluster of several distinct spots. The most widely accepted explanation was that these spots were deposits of salt left behind by the sublimation of water. This suggested that Ceres may have, or still has, some form of geological activity capable of bringing water or brine to the surface, where it quickly evaporates, leaving behind bright, reflective residues. These findings challenged previous assumptions about Ceres, offering a new picture of a dynamic and complex world. The possibility that groundwater or brine pockets exist beneath the surface raises intriguing questions about the potential for life elsewhere in our solar system. Ceres is often described as an icy world with a rocky yet porous surface. Unlike most asteroids, which are composed primarily of rock and metal, Ceres stands out for its unique composition. Its surface is made up of a mixture of water, ice, and hydrated minerals, including clays and carbonates, giving it a less dense structure than its rocky neighbors. This composition implies that Ceres contains a significant amount of water. Its rocky surface is porous, with ice and other volatile materials trapped inside, making it more similar to a comet than a typical asteroid. Scientists believe that Ceres has a distinct interior consisting of a muddy mantle and a core rich in water ice, which accounts for about 50% of its total volume. The mantle is thought to be a mixture of rock and brine surrounding a core potentially made up of denser materials like silicates. The presence of substantial water ice suggests that Ceres may have hosted liquid water in the past, particularly if its core was heated by radioactive decay early in its history. This internal structure sets Ceres apart from other asteroids and raises fascinating questions about its potential for geological activity and the role of water in its development. Moreover, the discovery of ammonia clay on Ceres points to the possibility that the dwarf planet may have originally formed in a cooler region of the solar system before migrating inward. The presence of ammonia could lower the freezing point of water, supporting the existence of surface brines. These insights into the composition and history of Ceres not only deepen our understanding of this captivating dwarf planet, but also provide valuable clues about the processes governing the formation and evolution of icy bodies throughout the solar system. Cryovolcanism is a fascinating and relatively rare geological phenomenon, especially when compared to the more familiar volcanic activities on Earth. Unlike traditional volcanoes that expel molten rock, cryovolcanoes, often referred to as ice volcanoes, eject materials such as water, ammonia, or methane. These substances can exist as liquids or gases in extremely cold environments. Cryovolcanoes on Ceres operate by allowing briny water with dissolved salts to reach the surface. When the salt water comes into contact with the vacuum of space, it rapidly sublimates, turning directly from solid or liquid into gas. This process leaves behind glowing, reflective salt deposits, which form the bright spots observed on Ceres' surface.